All right, Mr. McDesmos is back and he's been practicing. And the probability that he hits the fairway is 0.62. If he hits the fairway, the probability that he hits the green in regulation is 0.57. If he misses the fairway, the probability that he will miss the green in regulation is 0.73. Find the probability that he hits the green in regulation. So this is our question. So if we want to answer questions like this, we need to know about something called the law of total probabilities. You also need to know a little bit about golf. Hopefully, you know that in golf, if you hit the fairway, it puts you in a good position to hit the green in regulation. And again, if you haven't seen those other videos, on a par three means you should get the ball in the hole in 3 shots. Means you should hit the green on your first shot. On a par four, hit the green in regulation on your second shot. Par five, green in regulation on your third shot. But if you hit the fairway, that helps with that. So students are always asking me, when will I need to know this? Well, I guarantee you that professional golfers have to know the statistics and the probability around this sort of stuff. So certainly an instructive example. Let's jump into it. What we can do, a tree diagram is really helpful in probability. So what we're going to start with is creating our tree diagram, and this is going to decide whether we hit the fairway or not. So that's our first event. So we're going to call that F. So the probability that we hit the fairway is 0.62. So therefore, the probability that Mr. McDesmos misses the fairway is 0.38. These are complementary events. They have to add up to 1. You either hit the fairway or you don't. And then from there, you either hit the green in regulation, given that you hit the fairway. So you hit the fairway and then you hit the green in regulation. And it says in the question, if he hits the fairway, the probability that he hits the green in regulation is 0.57. So the green, given that you hit the fairway, is 0.57, which must mean missing the green or not hitting the green, given that you hit the fairway, must be 0.43. Similarly, if you miss the fairway, the probability that it will miss the green in regulation is 0.73. So that's this one. So miss the green, given that you missed the fairway, is 0.73. And so again, these are complementary events. So if you miss the fairway, the probability that he'll hit the green is 0.27. So get a tree diagram that looks something like this. And so the question is, find the probability that he hits the green in regulation. So what is the total probability that Mr. McDesmos hits the green in regulation? Well, let's have a think. We need to sum up all the situations where the green is hit in regulation. So you either hit the fairway and then hit the green. So you're going down this branch and then this branch, or you miss the fairway and then he misses the fairway and then he hits the green. So we're either going here and here, or we're going missing fairway, hitting green. So either there or down there. So it would look like this: the probability of F multiplied by the probability of G given F, plus the probability of not F multiplied by the probability of G given not F. So it looks like that. And that is essentially the law of total probabilities. Let's just crunch the numbers for that. Oh, and here's the branches we're going down. We're going down here and here, and then here and here, just to highlight that. Okay, so 0.62 times 0.57 plus 0.38 multiplied by 0.27. Chuck that in your calculator, get 0.456. That's not bad odds, just under 50% chance that Mr. McDesmos hits the green in regulation. And yeah, that's essentially the idea of law of total probabilities. One other thing I'll just point out before we sort of write down the formal definition of the law of total probabilities is this idea. F multiplied by G given F is the probability of F and G. You hit the fairway and you hit the green. It's the intersection of those two events, right? You hit the fairway and then you hit the green. Similarly, not hitting the fairway and then multiplying by not hitting the green, given that he missed the fairway, is the probability of not hitting the fairway and not hitting the green, and then everything in between, right? These two in between. So I suppose just to point out another way that we could express the law of total probabilities, we could say the probability of hitting the green is equal to the probability of hitting the fairway in the green plus the probability of not hitting the fairway and then hitting the green. So it's another way to express the law of total probabilities. But here is our sort of formal definition of the law of total probabilities. The probability of some event A happening is equal to the probability of B multiplied by the probability of A given B plus the probability of not B multiplied by the probability of A given not B. So hopefully you can see how that sort of works in this example here. It's quite wordy. I mean, it can be hard to interpret these questions sometimes, but hopefully that gives you something to sort of work with and work through these problems with.